Welcome to qnawire.
In this problem, we're asked to consider acetylene and nitrogen. We're told they're both containing a triple bond, but they're very different. A, already did A. Write the Lewis structure. So I'm done. There's the Lewis structure for each one, nitrogen and acetylene. Okay. Then what is B here? By look at the enthalpies of formation. Okay. Look up our enthalpies of formation. And for acetylene, we get 226 and kilojoules per mole. And for nitrogen, we get 0 kilojoules per mole. This is more stable as it is smaller, lower heat of formation. Next, C. C says, balanced chemical equation for oxidation of N2 to form N2O5, both G's, and C2H2 to form CO2 and H2O. Okay, that's easy. Let's do that. N2 plus O2 to form what did I say? N2O5. And I like to keep this 1, so I believe I'll just go 5/2 and call that good. Then for C2H2 plus O2 yields CO2 plus H2O. So I believe I will need a something over 2 here. I will need a 2 here, so I'll need a 5 there. Okay. There's E, or C, I mean. Now let's do D. Calculate enthalpy of oxidation per mole for N2 and H2, excuse me, C2 H2. And we're given N2O5 is delta H of formation of 11.30 kilojoules per mole. Okay, this doesn't look like this will be too tough here. So for N2, we will have 11.30 kilojoules per mole times 1 mole minus, and it'll be 1 times 0 plus 5 over 2 times 0, which will equal 11.30 kilojoules per mole of N2. And then for C2H2, this will be a little bit more to it than this. Let me go down here. This will be 2 moles times negative 393.5, and this is CO2, plus 1 mole times negative 241.82 kilojoules per mole, and this is my heat of formation of H2O, minus, whoopsie, okay, and then we're going to subtract from that 1 mole times 226.77 plus 5 over 2 times 0. Perfect. I believe this will be, I'm going to double check this. Okay, let me grab my, I made a mistake here. Don't have my computer, or excuse me, my calculator on me. There it is. Sorry about this. Oopsie, I just closed my other computer, so now I can't see my other parts of the problem. How wonderful. Let me do this quickly. Clear, clear. So I've got 2 times negative 393.5, enter, plus, parentheses, 2 times negative 241.82, close parentheses, enter. I lied, that was wrong. 2 times negative 393.5 plus negative 241.82 minus 226.77. Yes, that is correct. So here are my answers for D. There we go. There's D. Now let's get to E. I think there's an E. Let me look. Okay. Blah, 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 blah. They both have triple bonds. Calculate the enthalpy for formation. Acetylene plus H2 to form methane. And where am I? Nitrogen plus H2 to make ammonia. Okay, so let's get this balanced here. If I have a 2 here, that gives me 8, 2 carbons, 2 carbons. And I have 8 of these, so I'll need this. Okay, we can do this. So first of all, let me do my heat of reaction for this one will be 2 moles times CH4 . What is CH4? I gotta go thermodynamic table for CH4. Hang on, thermal chemical data table. I always use University of Wisconsin. And CH4 is negative 74.81. And then methane, or excuse me, C2H2 is 1 mole times 226.73. And this is kilojoules per mole. 73 kilojoules per mole plus 3 moles times 0. Okay, there we go. Let me grab my calculator again here. 2 times negative 74.81. And there I will subtract. So I get my delta H equal to negative 376.35. I want to make sure I've written this right. This would have been a 3. 2 times my CH4 Okay. And then last but not least, for my NH3, we will have a heat of reaction will equal 2 moles times my NH3 is negative 46.19. And we'll subtract from that 0 and 0. And that will equal negative 92.38 kilojoules per mole. And this is per mole of N2, and this is per mole of C2H2. And we're done.